version of Math 9. It's not really in the curriculum, but I thought I'd teach it to you now anyway. It's a nice extension from what we did the previous day with multiplying by a constant or a monomial. So I thought, hey, I think you can do it. Let's try it. Okay? Now, once again, how do we multiply? Well, we can use that chart. And remember how I said I like that chart? Well, this is why. Because the chart works for the binomial multiplied by a binomial as well. So once again, we're going to take the term and then put it on one side of the chart. And then we'll take the other bracket and put it on the other side. And then we're going to fill the chart, of course, with the tiles. Whoa, what just happened there? Fill the chart with the tiles that the product creates. And please be careful of the signs. Once again, positives are white, negatives are dark. Okay? Here we go, x plus 1. So x is the rod, plus 1 is the one small square. X plus 3, that's an x with the rod, and then 3, 1, 2, 3. So let's go ahead and multiply. So when I multiply x times x, that's x squared. There's the nice large square. And then we have x times 1, that's 1 rod. X times the 3, I think there are 3 rods here. And finally, 1, 2, 3 small squares. So in essence, what we have here is x squared plus 3x plus another x plus 3. And of course, we can simplify that. And that just becomes x squared plus 4x plus 3. So your multiplication statement is as follows. X plus 1 multiplied by x plus 3 equals the answer x squared plus 4x plus 3. Okay. Try the next one then. Okay, so similar. Let's draw the algebra tiles. So x minus 1, let's put that on the vertical part of the chart. X minus 1 this time, dark and square. 2x over here, so 1 rod, 2 rods, minus 3. 3 shaded squares. Okay, fill in the chart. Let's do the multiplication. So x times x gives you the x squared. X times x, another x squared. Okay. And I go a rod, which is x times the negative 1. That's negative 1 rod. Guess here's another one. Negative rod. A third negative rod. And then over here I got negative 1 times a rod. That's another negative rod. Another negative rod. And then the negative 1 times the negative 1, that's a positive 1. Negative 1, negative 1, positive 1. Negative 1 times negative 1, positive 1. And so lo and behold, what do we have? I see 2x squareds. I see minus 3x. I see another minus 2x. And I finally see a positive 3. And that simplifies to 2x squared minus 5x plus 3. So, our statement, x minus 1, 2x minus 3 equals to 2x squared minus 5x plus 3. Okay, we've done 2 examples by doing the chart. Math, you know, is all about patterns. So, do you see any patterns involved here? Can you find a way to tell me how I can multiply a binomial by a binomial? I'll let you think about that. If you're watching this with a friend, talk to your friend. No friend next door? It's just you and me, hey? Remember how in the previous lesson we distributed? Do you see that distributing idea again? Can you see how x times x over here gave us the x squared? X times 3 gave us these 3. And then can you also see how the 1 times x gave us the x rod, and then 1 times 3 gave us the 3. Let's try this over here. So, x times 2x, that gave us the 2x squared. See those? x times negative 3 gave us the minus 3x over here. Negative 1 times 2x gave us the 2x down there. And then negative 1 times negative 3 gave us the 3 squares there. So I hope you see the pattern now. We often call this the distributive property. Okay, where in the pattern really is each term in the first bracket must be multiplied by each term in the second bracket. So each term in first bracket must be multiplied by each term in the second bracket. So, using this pattern now, go ahead and multiply. So once again, distribute x times x, that's x squared, x times 7, 7x. Negative 2 times x is negative 2x. Negative 2 times 7 is negative 14. Then finally combine like terms. The 7x minus 2x gives you 5x. So there you go. That's it. Okay. You try part B and C. And I know the numbers are bigger, but the idea is the same. Go for it. 2x, 3x, 6x squared. 2x minus 4 multiplied together, negative 8x. 1 times 3x, 3x. 1 times 4, negative 4. 6x squared, negative 8 plus 3 is negative 5x. Minus 4. Voila. C'est fini. C. Same business. Okay. Distribute. So 3 times negative 2x, negative 6x squared. 3x times 5, 15x. Negative 1 times 2, negative 2x. 1 times 5, 5. And once again, combine them together. Done. Okay. A few more on the next page. You can try these yourself. Or at least D. Maybe E and F I can show you. If you're freaking out about E and F, you're like, where's the other factor? Well, remember, square just means take your polynomial and multiply it by itself. So for F, same business. X minus 10 times x minus 10. Now, can you do it? Cool. Now, these three examples, D, E, and F, are really three important products. 2D is actually called a difference of squares because you're going to be multiplying the difference. Why we call it difference of squares? Look, what happened was that when we multiply this out, a times a, that just gave us a squared. Look at our answer, x squared. And then the middle terms, that was negative ab, and then this is ba, or just plus ab. You see those middle terms? They always just cancel out because a equals 0. It's like a zero pair. And you're just left with the last term minus b squared. So that's why we call this a difference of squares. See? Something squared minus a difference, right? Something else squared. E and F are called perfect square binomials, and if I were to ask you to multiply this out, you'll always see the following. a times a is a squared, and then the middle term here is always ab, and then this is always ab or ba again, so there's always going to be two of them, so I'm going to do 2ab plus b squared. So a lot of teachers will ask you to memorize that. I'm not going to ask you to memorize, I'd rather have you understand. And similarly with a minus b, if you were to multiply this out, you'll get the a squared. You'll get now minus ab with another minus ab, so that's minus 2ab. And then negative b times negative b, of course, is just positive b squared. So notice how this one looks very similar to the previous one, except minus here, plus here. Okay? So, as these exercises, it's up to you how you want to multiply these out. You can use the shortcuts, which I just showed you right here. Shortcut. Oops, I guess I should be highlighting this whole thing. Shortcut. 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 Or just expand it out and do the multiplication as before. It's up to you. I'll let you try all of these on your own. I'm just going to give you the final answer, alright? And I hope that you can try them. Come back when you're done them and double check your answer with mine. Okay? The rest is up to you. Difference of squares. Difference of squares. Difference of squares. Now this is 2p all squared, so that's 2p times 2p. So write down 4p squared. And then 6 times 6 is 36. Once again, difference of squares. Here we have perfect squares, the positive ones. So this is like a plus b, which gives you a squared or x squared. And this is the key thing, plus twice of the two terms multiplied together, 2ab. So 2 times x times 7. That's 14 of them. And then b squared, that's just 7 squared or 49. Same thing here for this one, m squared, 2 times a times b. 2 times m times 3. 6m. 3 times 3 is 9. Perfect square again. But 2b all squared is 4b squared. Remember 2b squared, that's 2b times 2b. So that's 4b squared. 2ab, so 2 times 2b times negative 5. That I think is negative 20b plus 25. And once again, if you don't like using those formulas, then that's okay. Just multiply it out, do it the long way, you'll get the same answer. 2ab. Done. Make the corrections if you need to.